Hello, everybody. Welcome back to the Net.lol podcast, where we are all in quarantine and hanging out, trying to figure out what to talk about that we would normally talk about at conferences. Instead, we're now talking about on our very own podcast. As usual, joined by Tom Nadeau and Dave Tucker. Kyle Mestry is out. Today we have special guest, Nick Buraglio. I've known Nick for a long time. Nick is an excellent dude in the networking community. He has been a blogger. He's been a thought leader. He's been general kind of pushing the edge of the envelope in research networks. And Nick, what's up, man? Thanks for joining us.
Absolutely. I think you've talked me up sufficiently that there's no possible way I can meet expectations now. Yeah, just keeping busy, keeping at home, and trying to make progress.
Keeping the bits flowing.
Redbeards.
Keeping the bits flowing and trying to figure out what's going to be next. You know, what's in the next 5 years? How does it fit in and go with what we're doing now?
So speaking of being at home, it's something I love to see. The only good thing that's come out of COVID is like the traditional managers that think you're not getting work done unless you're in your cubicle have been proven wrong, hopefully forever, and we can shoot them into the sun.
Yeah, hopefully forever.
Right. So how is working on real networks and architecting, designing, and building networks from home different from being at work, if at all, for you?
So it's really no different for me because I've been remote for many years, and even with that, most of my experience is in service provider style networks or very large campuses that sort of emulate service providers. So being able to work on things remotely and just having the tools and the infrastructure in place to have out-of-band access and touch things from, a great distance away is just sort of second nature to the things that I do. One of the things that I do think is sort of coming to pass, and I agree, the working from home thing and, rear ends in the seats to prove productivity never really made any sense to me either. But I think that, there's a lot more of the adoption of, some of those techniques of, getting in remotely and making sure you have, a back channel or backdoor access to, manage a network. I think those have become very, very, very publicly important, right, as managing infrastructure from afar when you may be used to, hugging the switches and things like that. It just isn't a thing anymore.
Yeah, the whole cloud thing. It took me a long time to, oh, wait, am I going to blow up my server that's 3,000 miles away?
Yep.
So how do you cope with that? Change control, like automation. These are things you're usually hearing, right?
Yeah, places that don't have some of those things, like automation, as much as you hear about it, I think is still pretty early in the deployment phase for most networks, right? Especially networks of any given size that have been around for a while, probably grew organically and, have existed for a decade or more. Like retrofitting automation into that is not really an exercise in technology. It's much more an exercise in figuring out where your technical debt is and then socializing it with the people that need to do it and getting buy-in, because it's different, could be scary. It's a shift to cattle, not pets, when you're probably used to saying, I know the IP addresses of every router in the network.
It's kind of like an organizational cultural change, right?
Yeah, it's much more of a social issue than it is a technological issue. And I actually have given a talk on this in the past where the overarching theme of the talk is like the technology is largely irrelevant. This is a people thing. There's 10 different ways you can do it, but if your people aren't on board, it isn't going to happen with any amount of success. But that's something that I think can't be said enough times. But from the cloud perspective, that managing that remotely is just, it's native to it, right? It's not like you're going to drive to Google's closest data center and pet the switches and the routers and the whatever you're managing there, the virtual systems. You're not going to,
even if you know where they are. Yeah.
Yeah. I mean, it's not like Tron where you can go into the computer.
Right.
As much as we may want it to be.
AWS announced that at reInvent.
Yeah. Is that what went on in the back room at the arcade in the 80s? Yeah, exactly.
I can't get through any conversations without at least one 80s movies reference.
It has to be, right?
Nice. So you're kind of talking about, remote programmability. I assume also like disaster scenarios. So are you actually dropping compute on around those edge switches, the edge of your network? Or are you still kind of just like using the compute that's on board on the the hardware, the networking hardware?
No, in most cases there's compute in the WAN. At each of the POPs there's, in most of the networks I've touched in my career, where we have remote networking, we also have what we call like analytics systems. So Brent, you're probably familiar with Personar, which is like a monitoring and analytics platform, like a performance testing system that was born out of research and education networks. Typically those get deployed at any strategic location, so there's compute there. I've seen increasing amounts of actual compute, like CDN type deployments or DTN type deployments on the WAN. So you've got, probably a couple U of networking equipment, 1 or 2 U of remote management stuff. So like, RS-232 console, some sort of back channel connectivity, whether it's, a T1 or a cellular connection or whatever else. Then, management Ethernet, got a couple U of that stuff, then power management, and then the rest of the rack is probably compute. So you're talking half a rack of gear for a major POP. And, that's what I've seen in most service provider deployments.
That's still a pretty decent amount of compute close, if you want to do cache or things like that. Yeah.
Yeah. And I only see that's just going to get more and more prolific, right? Especially with, and I'm going to buzzword it here, especially with 5G deployments where, you're going to have to push all of that content as far close to the edges, it's as far close to the eyeballs as you possibly can. It's like 20 years ago where everyone was putting squid caches in to where their main, aggregation points were. All it's old is new again.
Yep. Yeah. Yeah. It's interesting you mentioned the 5G thing, because that's the thing we're working on right now, and that's exactly what's happening. It's really convenient because it's vRAN. The vRAN deployments are a half rack of servers anyway, so let's add some more. And you can wheel out 2-3 racks right in an edge location, and then you've got lots of computing power, or lots of cache, or lots of storage. Pre-positioned cache space. Yeah, and that's it seems to be like the kind of evolution anyway, even without 5G. It just makes sense to put that stuff closer, And
I totally agree. And
but just like there's a concept that I think is more important in networking nowadays than it has been in the past, probably. And it's stuff that we've been doing and maybe didn't realize it, but the concept of data gravity, right? So we're always going to be fighting time and space in networking. So there's a couple. So you're fighting against physics. The longer the data has to travel, obviously, the slower it is. But we're also fighting against cloud costs of storage. So totally free to pump data into clouds. Super expensive to get data out of clouds. So
Well,
the
and
more
also the hidden
processing on that
cost.
edge. Yeah.
Yeah, the
Sorry, go
hidden
ahead.
cost of that is also connectivity to them, right? So you can never discount the port costs, the cross connect fees. You
That's
may
what I
be
was going to say.
paying,
Like,
Sorry.
there's no free lunch moving that out to the edge either.
yeah,
What you're doing is you need more backhaul bandwidth to those
yep,
places and more power to some of those places. This is kind of the existential challenge. Like when with 5G, you mentioned 5G, and like when I was at BT and we were trying to roll out fiber to the home or the curb, this was one of the biggest issues. Was like you you can have a terabit switch connecting all the houses on this street at the end, but the thing that's connecting it back to, you were lucky if it was a fiber, even at that point. And it's not cheap putting in a new one. Even if you're doing aerial
yep.
fiber or whatever, rural, that's that's always the biggest pain in the ass, frankly, with this stuff, right?
Yeah, I mean, and we see that a lot here, and Brent probably does too, coming from a reasonably rural area like I do. Is that you've got copper in the ground that's at a minimum 50 years old. I mean,
Yeah.
there's stuff around, a lot of stuff around like my hometown that's still paper wrapped copper. And
And the interesting thing with that is, like we found in the UK, is people don't appreciate the fact that the copper ages. Not only oxidizes, it literally disintegrates. And
yep,
if we've all played around with Cat 6 today, even brand new Cat 6, you bend that stuff 4 times and it snaps right inside the jacket. Imagine 50-year-old copper that's sitting out there that's half its thickness now because it's corroded around, and
yep.
that was
It's
the
got to
problem
deal
we
with
were
the
having.
freeze thaw.
That was the problem we were having. Like you could not signal the bandwidth. Like you could not send that much RF up the wire. It just wouldn't work physically.
Yeah, they're probably dealing with the same thing, right? Freeze thaw. That will degrade things very quickly. And it's funny because in 40 years or 30 years, we're going to see the same thing with fiber, because fiber gets brittle too.
Yeah,
And then we're going to have to do this all over again. Yeah.
That's the thing that like a lot of the FTTP deployments in the U.S. now, they've discovered plastic fiber, which is great because it's like 1/10 of the cost of glass. But what you said, there were different generations of that stuff too, and
Yep.
it wouldn't surprise you, I'm sure, at all to find that the providers that laid that stuff took the cheapest roll they could find at the time.
Dude, I've seen deployments where they don't even have a locate cable in it.
Yeah, that's what I mean. It's just, well, let's throw it in here. And hopefully, the good news is like around here anyway, with in New Hampshire, the fiber is aerial, so it's easier to swap out later. Have too much fuss, but that's an often overlooked, sort of thing.
Yeah, outside plant is a whole different bird when it comes to networking. And I've talked about this on another podcast, on one of the network collectives. We talked about, the differences between, a service provider networking and enterprise networking and even campus networking, which is really kind of just a weird mix of both. But like, you don't in a normal deployment, you don't have to worry about a squirrel chewing through your fiber cable, right?
Yeah,
but like,
blowing up the transformer next to it. Yeah,
right. I mean,
that happened here last summer, actually. Yeah.
Yeah, manholes flooding and exploding. I mean, those are like big. I remember my internship in college. A part of it was outside plant. We'd go down the manholes, cover fiber with It's called horse snot, but basically like a lubricant, and jam it up into the
Yeah,
conduit,
pull it
pretty
through the
wide.
conduits.
Yeah.
But the thing with those conduits, like a friend of mine, he started out working down at uh, U Texas or Texas A&M. I can't remember now. He has a funny story of the manholes there, the conduits that ran through actually were parallelized with power runs. So they had three-phase power bars running through the same right near. And one time it flooded, kind of like what's going on now in Texas, although when all that thaws, it's got to go somewhere. And it flooded the manhole covers, and one of them is this video. It exploded, like the cover flew off, and the whole thing blew up. Good times.
Well, it's funny.
Outside plan is an art form.
Yeah, Nick and I both kind of started in the university setting doing research networks. And really, if anybody out there is new to networking, I couldn't recommend more starting out in university setting because you just get to touch everything, right? You probably have, and it even goes up the stack as far as like healthcare. You get exposed to things like PCI, credit card data, all the privacy issues. You can touch security. Wireless is huge. I mean, the breadth of what you're going to pick up there, and you also have the opportunities to like kind of move into service provider work. All those places they're going to be dual connected. They're going to participate in regional networks. I mean,
And the ops teams are so small that you can actually do a lot of stuff.
you do
Right?
everything.
You're not going to go work at a big telco and they're going to say, "Hey, you want to drive a truck and pull some fiber this week?" Probably not.
On more than one occasion, I was configuring BGP, got it done, grabbed crimpers, walked to the data center, crimped cables, right? I mean, that was a normal day back then. You definitely learn all the layers, and you're probably having to do some programming because because like you said, there's not enough people. So in the old days, before automation was a word that anybody used, we just had sysadmin scripting, and it was mostly done in Perl, which is my favorite language.
Out of necessity, right? It wasn't like a job description. It was like damn, I don't want to do this. I've done this 20 times. I don't want to do it again.
Nope, it's other duties as assigned.
Yeah.
But wasn't it a necessity based on resourcing? So I used to give people so much like shit when they would be running like the DNS server on the Sunbox buried in the corner, like right next to the dumpster, underneath like the sprinkler system, right? And it was going to be one or two people at best that even knew how it ran, but they were kind of doing these DevOps / NetOps things back then. But now now it's cool. I would say the difference is now people need to, like, everybody needs to understand how it works instead of just like the one or two.
Well, that's what I mean. It's like it's his own job now that gets baked into the thing. Before it was, hey, can you do a little of scripting after you've crimped some wires,
Yeah, exactly that. I mean, I remember learning CF Engine 20 years ago, so that we could automate all of our FreeBSD systems at the supercomputing center. It's like, well, we use CF Engine to manage this. You need to learn it. And so I sat down and learned it. And they're like, oh, you're the expert now. You get to upgrade it. So, it just became part of the job was managing a bunch of systems. And since we had like 6 people for the whole supercomputing center, we automated, using CF Engine and a bunch of Perl, most of the hard things or repetitive things we had to do.
Yeah, but that's the cool part of those gigs. You'll learn all that stuff.
Yeah, and Nick, you've been one that's kind of reluctant to be a full-time programmer, and I admire you for this because sometimes I miss being a full-time networking guy.
Nobody wants to run the code that I write every day. It's not. I mean, and I'm going to be a real jerk when I'm writing it because I don't enjoy it, and it's frustrating to me. So, and also I don't like Python. There, I said it. I don't like Python. I want to write things in Perl or Shell.
Yeah.
So
scripting or coding. Let's not jam them all together, right?
Yep. I mean, I learned it sort of out of necessity. I did computer science a little bit as a minor in college. I never finished it because I didn't like the programming. So I can do it in a pinch, but I will always avoid it if I can get away with it.
Yeah. So do you find yourself using just other people? So there's enough tools out there where you don't feel the undying need of bad engineering to reinvent the wheel. Is that kind of what you're seeing, or are you still seeing gaps?
So there's still gaps, but if at least for me, like I know enough to be dangerous. So like you said, Python is programming, and like Perl and Shell is like it's sysadmin scripting. I mean, for the most part, you could probably argue that, but the Python stuff, I know enough to be dangerous. So if somebody else has written something, or at least a framework of something, I know enough that I can probably extend that if I need to. And if I can't, I know enough really good developers that I can go, okay, what am I missing here? And they'll help me, or they'll just do it. So, I don't mind it, but I am a very firm advocate against reinventing any wheels. Like we have enough to do. I don't need to do anything twice that somebody else has already done. Unless there's just unless it's like I wrote it, and then in which case you probably should rewrite it. But that kind of mentality, like let's just get the thing, figure out if somebody else has done it, adjust to what we need, move to the next thing.
Yeah, it's funny you say that. I mean, we were talking with John the other day about DevOps, NetOps, and that was one of his motivations for working on it, right? When he was talking with you, Brent, the first time, the bus ride thing.
Yeah.
Story about the bus ride and all that, and he was describing like why do this? And it was really kind of what Nick was saying, right? It was, first of all, it's nice to have a framework and everything, so you don't have to reinvent 80% of this thing. But then actually the sharing of the stuff is important too. And now we see all that, like today with all kinds of stuff. It's GitHub, GitLab, whatever, GitOps, and also sharing of all that stuff. Playbooks, etc. And it's kind of building on itself. It's funny because it's how the observation I've made is how non-super secret that stuff is anymore. But it used to be treated like the crown jewels at MCI or somewhere, right? You know what I mean? Like, and you all are like, yeah, it was just a means to an end, right?
Yeah, I mean, there was a lot of here's our competitive advantage, and it's this like goop that we wrote, some guy wrote or some gal wrote, and then whatever. But there's enough out there now that, like, I mostly taught myself Ansible. I taught myself enough Ansible to use it, and then went and talked to our main Ansible guy and said, okay, here's how I'm doing all these things. Tell me how bad this is. And he's like, change this stuff. And then now it's like, if I have to do something more than 3 times, I just write Ansible playbook for it.
Yeah.
And then move on.
And the point is, like, you don't get credit for, how super optimal or sexy that code is, as long as it achieves the goal. Next.
And right? I'll tell you what, that's exactly the draw for me, because that's pretty much 100% how I approached writing Perl and Shell. Like, it isn't going to be sexy. It's probably going to be full of comments, because I'm going to forget what I did like a half an hour after I did it. I'm going to shove it in it.
More comments.
You're like a goldfish.
Yeah, I mean,
that's good.
And I'm going to shove it in SVN or some other repo back then, CVS probably, and then
CVS, yeah.
Go back and revisit it when I need to.
Case.
I remember putting things in RCS, so it's like,
yeah.
So you're pretty much going to find the oldest language, the oldest code repository, and everything from 20 years ago, and use that. I mean, this is real networking, folks. Now, Dave, as the young buck, tell us where we're all wrong and old and boomers.
No, like I was going to say, like I think it's quite funny that the competitive advantage thing about being the code and being all of this stuff that we write, all of the glue, and in reality, the competitive advantage is about having that team of people that actually understand what the hell is going on completely throughout the stack. And in a small team, that's almost implicit, right? There's maybe 6 of you, and a couple of you are looking after infrastructure apps, a couple of you are looking after the infrastructure, and you're all talking together, and that's fine. When you scale up that organization, that's when things tend to go wrong, because you don't have those pieces to connect anymore. So it's I'm kind of curious, Nick, like how have the teams that you've been on, how have they grown over time, and have they kind of reached that inflection point now where there are more people in there than there are people that can closely understand what's going on?
So I've been in multiple organizations where, the varying sizes, right? And I think the hidden comment here is that at a small size, it's very easy to see that the people are the valuable resource, right? It's the FTEs, it's the people that actually care about the job that's getting done that are valuable. The work that they do is a byproduct of that. When you get to a certain size, it becomes harder to see that, because an individual contributor becomes more like a tree in the forest than, the forest itself. So, as that grows, that's just part of the growth process. Where the trick is making sure that management understands as it scales up that, like, yes, we're getting bigger. There's going to be a point where we don't have a single set of people that understand every single aspect of every piece of technology, but they talk to each other and it's reasonably documented. And by the way, we still understand that the people are the important thing. And I think that gets lost a lot, like a lot. Now, I've been lucky in my career that I have purposely sought out organizations where they understand that the people are the valuable assets. And I have stuck in that space because of that, because I want to do cool things. I don't want to be a button pusher and there's nothing wrong with that. Some people like that, right? But that's just not for me.
Yeah. It's funny you describe it like that. I was just talking to my wife at lunch about the mythical man month and how a lot of people have forgotten about this very sage little nugget in the historic record of computer science and stuff. It's still true today. Adding more people does not necessarily make the ship go faster. Sometimes it makes it slower.
It almost always makes it slower while they spin up, right? Because you can't hire a person unless you are an absolutely massive organization that has every job description and every function of that job description noted, and you just hand somebody a playbook to do their job. And those places exist. I know, because I worked at one back in the 90s.
Yeah.
And unless you're one of those, it's going to take a year for a new employee to come up to speed. They may be able to be technically proficient, but technically proficient is like a third of the job at best, right? Yeah. It's integration with the team. It's understanding
the people
who to talk
part,
to. Yes,
that's the hard
people part is always the most important.
So I know we're not going to solve all the people problems, which is sad. But technology, that's something we can do something about. So I'm kind of interested now. This is a nice segue into, things are changing, technology's changing. And I guess one of the things I've been thinking about since COVID has hit is kind of how all of the data access patterns have changed. Right. We used to have this thing where you had an enterprise, and the enterprise was like, all of my employees are in the office. Cool. All of my stuff is in the data center. Cool. Or, everything's going to be controlled through corporate VPN. And now guess what? Everybody's distributed. All of that corporate VPN stuff has to go away because it's just overhead. And I feel like things are changing. So I'm kind of curious, Nick, do you see similar things changing? Do you see that having to impact the way we build ISPs? And what do you think's next?
So there is definitely an impact on ISPs. That's been very well traveled, especially in the small regional ISP space, where they may not have capacity planning or other types of plans going forward, or especially in some of the rural ISPs where they may not have upgrade options. Right? It just may be I get a feed from AT&T, I pay X amount of dollars for whoever, right? It doesn't have to be AT&T. And that's what I can get, and that's what I distribute out. I have no other options for fiber. I have no other options for anything. And that's been a squeeze. That's been really hard. And I definitely think that it has opened people's eyes to a number of different things. The first one being we should have had a process in place for looking at our capacity planning. Like when we hit this number, 70% of our upstream at peak, I should already be looking for what my upgrade options are.
One. Yeah.
Right.
Because it does take months and months sometimes to get that. Sometimes you need physical build out, right? Even for stuff.
Yep.
And
sometimes it's going to take construction. It's a big deal to do that. And because it's hard, it often gets kicked down the road. The other thing that I've seen is that, there have been service providers that have started to impose unwritten rules on things. Like in the US, there's been a few that have said, oh, by the way, you can't use your upstream bandwidth. Like you can't peg your 30 megabits you get upstream, your 10 megabits you get upstream. It's not written anywhere in the EULA, but it's detrimental to the network, so you can no longer do it or we'll shut you off.
And they'll shut you off or throttle you back. Yeah.
Yep. So that's been a thing. I did a project at the very beginning of COVID here in the US, started in March, because DNS has been sort of a little pet project of mine for many years. I've run bind servers and stuff since the 90s, and I am I'm a very staunch advocate of service providers running their own recursive resolvers. I don't like the public resolvers for a bunch of different reasons. But I started measuring. Are you worried about
the privacy concerns with the SPs?
I mean, that's sort of that's
kind of the other side of that coin, right?
Yeah, I mean, that's an ancillary problem, but I think DNS is DNS, right? Your query is going to be out there no matter who you're talking to. I'm more thinking about it from the perspective of round trip time of queries to Anycast locations.
Quality versus
that's quality of experience
with the tunneling approaches.
And I mean, that's a bigger problem than people think. So I spun up a project and I got a bunch of different people to install smoke ping agents all over the world that just queried a big list of the public recursive resolvers and tracked the latency of the queries over time. So that's another little pet project thing that I still have running. I think I haven't looked at it in a long time, but it should still be there.
Yeah, that's cool. And I mean, that's like for me the issue with I run a bunch of my own bind-nines and because my upstream provider does funny business with the DNS queries and rewrites them sometimes and all the usual stuff. But the problem is that the tunneling mechanisms today that exist, they're cute and they work in the steady state. But when things go crazy, or like my power goes out and the whole house reboots, then everybody sits around for a few minutes until a tunnel is reestablished and all the routes are, it's far from a simple, seamless solution. And then, like you said, shouldn't the provider be offering this? Isn't that what we're paying them for? Yeah.
I mean, not running recursive resolver as a small service provider, you're only doing yourself a disservice because the long-standing network operations mantra is it's always MTU unless it's DNS, and DNS will make an interruption in a service appear to be a total and complete outage.
Be catastrophic, yeah.
Yeah. We
found that recent, with Kubernetes. Kubernetes is 1,000 little atoms running around in a big ball, basically, and the way they talk to each other is DNS. You don't statically program how to get from here to there. So they make a DNS query, and if you get wedged in the middle of one of those millions of DNS queries you're making over the course of a day, the whole thing freezes, waits, which is cute if the DNS resolver container is running on that itself.
Yeah, then you've got a race condition.
Then you get a really good recursive resolution problem. Yeah.
Yeah,
so it's funny how the one observation I've made, and I say this all the time, I call them the non-sexy nuts and bolts. I mean, you just said it. MTU and DNS. Half the people that are coding today have no idea what those things are or why they matter. They're just like, yeah, I got a DHCP address and I'm cool. Let's go.
Yeah,
And
if you want to open up that can of razor blades and hate, I can go pretty deep on that one.
I'd
It's
like to,
like
because I've got my own can of whoop ass right here with that stuff. You know, I'm going, come on,
my
let's make
my
the
bit.
simple stuff work.
Yeah, my biggest complaint is that, was one of the things that Socket Plane was trying to solve was that container networking is networking in name only, right? It's like not done by anybody that knew networking,
Yeah,
and it's the bare minimum, and it assumes a bunch of like really gross stuff like, oh, by the way, I'm going to NAT everything, and we got to poke holes through the NAT. And I'm using Linux Bridge, which is like 100 years old, and
yeah,
I don't need to know any networking to do this, and it just makes my brain hurt. And the biggest one for me, and Brent knows he can smell this coming, is that V6 didn't work for the
yeah,
longest time.
yep.
And that's a huge problem for me. And even now, right? Like,
And
there's
then
a
it kind of
government
half
memo.
worked for a while, and I had the same heartburn. I was like, God damn it! I thought this was supposed to work.
Yeah. I mean, I run V6 only, so like when that doesn't work, that's a problem for me.
Right.
You'll be happy now.
In fact, that was one of my experiences, was trying to get a V6 only bind 9 to run in Docker. And it was just like, ah!
Look, you guys are the 1%. 99%, the rest of the world's still on V4. All right?
I know.
I that's actually an inaccurate measurement, but we don't have to go down that road.
Here comes the table pounder.
It's a tough crowd here sometimes, so don't worry. It's cool.
So let's talk a little. Before we wrap, we gotta talk a little bit about control planes here because we're a bunch of network nerds. And so, Nick, I know that you're a fan of segment routing, as are some other folks out there. It's becoming a bigger thing. Convince me why the Father, Son, Holy Ghost of IP, BGP, MPLS is no longer good enough for your network.
I wouldn't say it's not good enough.
MPLS tattoo on my lower back removed, or what?
No, not at
traffic
all.
engineering?
Your tramp stamp, your MPLS tramp stamp.
Right.
Sorry, that's it. So I think that it's really just an evolution, right? Especially SR MPLS, right? You get all the benefits of MPLS traffic engineering and label stack and steering and all of these great things that you get with MPLS, but you don't have to run a secondary signaling protocol, right? So you just stuff another TLV into ISIS or OSPF if you want to, and that carries your label stack, so you can turn LDP off, right? You don't have to worry about LDP anymore. And more importantly, you can turn off RSVPTE because it's going to handle your path signaling and your fast reroute and all of those other sort of complicated things that RSVPTE used to do. But, and here's the really big selling point, it does that without having to keep state in every single box along the path, right? So for anyone that doesn't know how RSVPTE works, essentially you're going to build a path through a series of routers, and you're going to have to touch something's going to have to touch the configuration of every single one of those routers so that it understands that it's part of that path. That's very heavyweight. And
it has to keep a bunch of state at each one of those hops, too.
Exactly. It has to keep all the state. You have to manage the configuration. It's just overhead that doesn't need to be there anymore. Whereas if I'm going to push a path with SR MPLS, or any SR technology for that matter, but SR MPLS is the one that I'm the most familiar with, you push that either manually, or you use a PCE, a controller type of device, to push that path into the very first device, and then it understands the whole path because it understands, one, the topology, and two, all of the label stacks on every device along the path and in the network. So it really is like I said, it's an evolution to a simpler way of doing the things that we have always done in MPLS. And it's a very easy, I'm air quoting here, it's an easy transition if you already run MPLS because you likely
turning
have
stuff off, basically.
Yeah, you've got in-house knowledge of the skill set. You understand label stacks. You understand, signaling the labels. You're already running probably the protocol that you're going to stuff the labels into. It just
Yeah.
it's a pretty easy migration. With the caveat of, it's probably, you got to pay attention, right? You can't just like do it one day unless you're kind of bananas.
Yeah.
That's never happened.
Well, so, and I love the prospect of being able to drive it all the way down to the edge, because MPLS on a Linux node never really caught on. And we're kind of, what we've done instead for that path isolation is basically IP tables or some kind of like brute force policy across. I never feel like there's a guarantee.
And a lot of that's very static, right? That's the other thing. That loses the signaling advantages. Like, you're not going to signal to a Linux node on the edge. Easily, anyway.
Yeah, in a data center fabric, you're absolutely right, Brent. You could signal that path directly from a node.
Yep.
If you wanted to. I mean, you could do it on the WAN too. If you control all of it, it'd be, not that much of a stretch to say, I'm going to signal this path all the way through from this host to a host on the other side, and I can take whatever, if I want to trombone traffic from Fremont, California to San Jose through Amsterdam, I can do that. No muss, no fuss. Just give it the label stack and it'll do it.
And I don't have to touch every node along the way. You can do that from the central point of the PC controller, right? And if the PC controller goes away, existing policy stays in place, right? So it's not it's not the full state being centralized that we kind of went down with early SDN stuff, right?
Yeah, you might lose some of your fast reroute, pre-calculated paths, and you might lose, any kind of like ephemeral stuff that you might be doing. But worst case scenario, your traffic fails back over to the normal IGP metrics of your network, right? So it doesn't go away. It fails open. And that was a really big selling point, because I think all of us in this call have done a fair amount of things with open flow, and there's a bit of overhead involved, and it doesn't really
Well, that was really the biggest thing with OpenFlow, is it was the way people were starting to deploy it was super static. Yeah. Despite having a controller or whatever. I mean, the actual network was very static, when you were you had to program everything, every condition, every failover condition, everything. And so it was like, if I look at it like the way you described SR, it's really like the opposite of SR. It's mostly automatic, and fails over to, again, a mostly automatic IGP setup versus a whole bunch of, stuff. And this was actually one of the failings of the original approaches. I mean, if you look at, like what Big Switch was doing early on and some of those guys, the controller got just bowled over by all of the traffic and things it needed to do, to compensate for the failover scenarios or the default punt conditions. Everybody forgot, like, if I reboot the whole network, we're back at time zero, and everybody needs everything set up again, and it's that and like the other way I've been looking at SR, like operationally, is there's just enough there that you have to mess with, like as an operator. You don't have to worry about everything. You can worry about a few of the important pieces, and the rest should work, assuming you have, like you said, a bunch of the other stuff set up.
Yeah, I mean, make no mistake, my office still runs off of an OpenFlow faucet-based network, and I love it for LAN stuff because I can touch one, technically two controllers, and I can manage however many switches, layer 2 switches I want with that. And I never have to log into that equipment again, basically. I touch faucet, I run a script that copies the config off after doing the linter on it, restarts the process, I'm all done. Yep. And that's nice, but it doesn't scale very well in the wide area network.
And that's what I was saying, like in these 1,000 node setups. That's what I was talking about. Yeah.
Yeah, that plus, when you're talking about, complex traffic engineering and stuff like that, SR is just, a very good technology to look at for that. And there's a lot of things that I think are going to happen with SR, because I really firmly believe that is the next evolution of most carrier networks. and probably mobile networks at this point too.
A lot of people are talking about it now. I mean, especially with a lot of the edge stuff, and then getting into the much more complicated edge setups today. If you're running 5G, MEC, all of these edge things, you may actually even have small local networks around those at the edges. Everybody thinks of an edge as like the traditional POP setup, where it's one in and a couple of access out or something. And this is, 1,000 radios in plus some other links and then backhaul, and then we're going to try to do some of the processing and everything locally before we send it up the straws the other way. And
oh, and by the way, you also have to think about what your backup paths are, because you're not just going to have one link in, right? You might have an RF link that's backup, and then a fiber for your primary. And
right, you got an RF microwave thing going out the back, which is really like a straw coming out of that thing. You've got 40 gig backhaul or something, and then you've got an RF straw out the back. You don't exactly want to be doing the same stuff in that scenario, and that, like, SR could fail over potentially better, and things like that.
Yeah.
So, yeah, cool.
Your paths, especially if you're using something like SBFD inside your paths, your failover is going to be incredibly fast. But, I think we can go deeper and deeper on that, but yeah.
Yeah, no, I mean, I love the topic. I think we'll definitely do a follow-up with you on that, because I want to get as many people, real-world people out there running segment routing.
I mean, the SR thing is we've talked to a bunch of people, and we have a bunch of other folks. We're probably going to do a whole, like, just SR. Let's go through it, and maybe go over an hour, because there's a lot to talk about.
Yeah, especially if you start talking about the variants.
Yeah. So, Nick, wrapping up, where can people find you, and tell us about your new podcast you started?
Yeah, so I'm on the Twitters at Forwarding Plane. I blog occasionally at forwardingplane.net, and started up a newer podcast called The Modem Show. It's just modem.show, and it's very similar to the Software Gone Wild podcast that was on Yvonne Pepiniak's IPspace.net, which I was the co-host of as well. So this is sort of a continuation and homage to all of the help he gave me and the others and letting us work with that. So we've got a couple published, a couple more in the hopper that should publish soon, but it's mostly like deep dive technical, take apart the protocols, maybe a little bit of witty banter, that kind of stuff. It should be fun.
Awesome. And we'll link to that in the show notes, guys. All right. Well, Nick, thank you so much. This was great. It was great to see you. I like the beard. Keep it up. Keep up the hard work with it.
Thank you for being on, man.
Oh, absolutely. For sure.
All right.